Academy. Today we'll be looking at Chemistry Paper 2-1, May, June 2018. So let's go through the multiple choice questions and let's see how we navigate through them. Okay, without much ado, let's begin. Quickly, the first question. It says, student investigated the diffusion of ammonia gas, NH3, and hydrogen chloride gas, HCl. Two sets of apparatus were set up as shown at room temperature and pressure. Now we see the sources of the ammonia gas, and we can see from here, you can see the source of ammonia gas, and here you can see a dark red litmus paper placed on this apparatus. And then on the other one, the hydrogen chloride gas, you can see the source here. Maybe this continue is deep in hydrogen chloride gas, and this similarly, this continue was deep in ammonia gas. And here we have a dark blue litmus paper. Now we say the dark red litmus paper in apparatus 1 change color after 30 seconds. The dark red litmus paper in apparatus 1, this apparatus, change color after 30 seconds. Okay? How long will it take for the dark blue litmus paper to change color in apparatus 2? How long will it take? So ammonia change color after 30 seconds. Right? And hydrogen chloride gas, how long will it take for it to change color? So first of all, here you have to know the rate of diffusion of each of the gas. The rate of diffusion of each of the gas. So which one diffuses faster? Okay? Which one diffuses faster? Is it the hydrogen chloride gas or the ammonia gas? So that will give us an informed decision. The first one is 60 seconds. The second one is 30 seconds. They don't diffuse at the same rate. If they diffuse at the same rate, then the answer would have been 60. The answer would have been 30. But they don't diffuse at the same rate. If after 21 seconds, the blue litmus paper will not change color. No. So the answer is between A and C. If it diffuses, if this one takes it diffuse first or take longer time to diffuse, then it will be the answer. So actually the answer will be A. Why? Because this one diffuses faster. This gas diffuses faster. So in 30 seconds, it starts to change color. Why this one diffuses slower? The hydrogen chloride gas diffuses slower. So in 60, around like a double of the time, or a little bit above double of the time, that's when the blue litmus paper will start to, the dark blue litmus paper will start to change color. So it will be around 64 seconds. Is that okay? It will be around 64 seconds. To be around 64 seconds. Yeah. So the first answer is A. Okay, we go to B. Now, the second question says chromatography. You know, this is always the chapter 2 of the chemistry. Chapter 1, chapter 2 of chemistry. Chromatography is a technique used to separate colored dyes. Okay? Chromatography is a technique that is used to separate colored dyes. Which dye has an RF value of 0.7? Okay, RF value is the distance you traveled, okay, divided by the surveyed front. Okay, how fast you travel, divided by the surveyed front. Surveyed front is usually 100. Here is like 100. Okay, so the surveyed front is 100. The surveyed front is 100, so the journey you travel divided by 100. Okay, the journey you travel divided by 100. Okay, so for example, look at this. So if from the baseline, this baseline, from here to this survey front is 100, so you begin to estimate. Let's begin to estimate. This one will be around 30, right? Less than 50. So 30 divided by 100, the ROF value will be 0.3. It's not 0.7, so it cannot be A. The answer cannot be A. And then if you look at B, it traveled, the dye, the color of the dye traveled from this dye, this particular color traveled about 90. See, if you are here, you are almost 90 or 85. Okay, if you divide it by the survey front, which is 100, you get 0.9. So which is not the answer to this. Now if you look at this, C is like 50 or 45. So if you divide it by 100, you get 0.45. D, if you look at this one, it's like 0.7. It's like 70, the journey from the baseline. You know, if from here to the survey front is 100, so a journey from here to here will be 70. 70 divided by 100 gets 0.7. So that will be the answer. D will be our answer. Okay, because if we have an ROF value of how fast the color travel divided by the survey front. So that will be our answer for this question. Is that okay? We'll move on to the next one. Now, it says which piece of apparatus is used to measure exactly 26.3 centimeter cube of a liquid? Okay, look, here we have a burette, here you have a syringe, here you have a pipette, and C, you have a measuring cylinder. Here you have a measuring cylinder. Here you have a pipette, here you have a syringe, and here you have a burette. Now to measure, when you start having decimal, centimeter cube in decimal, like you have 26.3. So this is a precise measurement. Measuring cylinder may not give you the accurate measurement. The best measuring tools to measure that is a burette. Okay, when you start having decimal in your values, in volumes, in volume measurements, then we use a burette. Burette is more accurate for measuring volume. Okay, now let's go to question 4. Okay, question 4 says the lead in a pencil is made up of mixture of graphite and clay. The lead in a pencil, is made up of graphite and clay. Now you can see the lead. This darked one in the middle of a pencil is the lead. Okay, and this lead is made up of graphite. You know, graphite is an allotrope of carbon. You know, we have two allotropes of carbon. We have graphite and diamond. Okay, so when the percentage of graphite is increased, the pencil slides across the paper more easily. The pencil slides across the paper. So if you increase the percentage of graphite, the pencil is able to slide across the paper more easily. Now, which statements explain this observation? A, the graphite has a high melting point. No. B, the graphite is a form of carbon. Of course we know, but that does not give it that prerequisite or the prerogative of being able to slide across the paper easily. There is an allotrope. Diamond is also an allotrope of carbon, or diamond is also a form of carbon. So even if you increase the percentage of diamond, it will not make the pencil to slide. Assuming diamond can be used to make pencil, but we don't use diamond for making pencil because it's not soft, it's very hard. In fact, diamond is the hardest substance on earth. So we don't use diamond to make a pencil. We only use one of the softest, which is the graphite. Now, the point I'm making here is that because it's a form of carbon, does not give that prerogative to be able to be sliding on the paper easily. Then C, graphite is a lubricant. D, graphite is a non-metal. Because it's a non-metal, does not give it that peculiarity of being able to slide over on the paper. So the true answer is that because graphite is a lubricant. Graphite is a lubricant. Okay, graphite is a lubricant. So it can easily slide on the paper. So we go to the next one. Here we have chlorine exists as two common isotopes. We know we have chlorine, isotope 35 and isotope 37. So chlorine exists as two common isotopes. And now information about these two isotopes are shown in this table. Now let's take a look at isotope 35. The number of protons is 17. You know, the proton number is same for isotope, okay? 17. And then number of neutrons is 18 for chlorine 35 and 20 for chlorine 37. Then the number of electron shares are both the same. The number of electron shares are both the same. They have 3 electron shares in this regard. Now, which statements explain why the two isotopes are of the same element? Why the two isotopes are of the same element? A, both have the same number of electron shares. No. There are other elements that are not chlorine that have 3 shares. So that does not make them part of this atom or isotope. Okay, then B, both have the same number of protons. Yes, you know number of protons you have determine your atomic number. Number of protons you have determines, I think B is the answer, but we have to go through C and D and see if there is a superior argument. Now, C is both have several auto share electrons. Both have several auto share electrons. So that they have several auto share electrons doesn't give the prerogative to be what it is, because there are other elements or atoms that have several electrons in the atmosphere. D, chlorine 37 has 2 more neutrons than 35. So what? So if you have 2 more neutrons than 35, does that stand to make it the same atom or the same element? So the reason for it is B. Both have the same number of protons. Both have the same number of protons. Is that okay? We go to the next question. Which substance is not a macromolecule? You know the meaning of macromolecule? Giant structure, huge structure. Diamond is a macromolecule. If you look at the structure of the diamond, open your textbook, you will see the structure of diamond. It's a macromolecule. We have graphite is a macromolecule. You see the structure of graphite. 1 carbon atom is bonded for graphite. 1 carbon atom is bonded to 4 other carbon atoms. For diamond, 1 carbon atom is bonded to 3 other carbon atoms. Silicon dioxide is a macromolecule. The only one is just a simple element, which is sulfur. It's not a macromolecule. Sulfur is not a macromolecule. Is that okay? So we'll move to the next one. Copper is a metallic element. Copper is a metallic element. Which statements about copper are correct? Which statements about copper are correct? Copper is malleable because layers of ions are in a fixed position and cannot move. Yeah, but even if the ions are in a fixed position, the electrons can slide past and the electrons in it can move. So I don't think this is the strong reason. The structure, number 2, the structure of copper consists of negative ions in a lattice. The structure of copper consists of negative ions in a... No, that's not true. Copper is a metal. Copper is a metal. So in a lattice, it's to be made up of both positive and negative ions. To be made up of positive ion. Okay, but there will be electrons that will be negative in it. So number 2 is out of place. So 1 and 2 they are out. So So probably we might look for options that have 3 and 4 if 3 and 4 are correct. So 1 and 2 point, they are wrong. So we go to C. Copper conduct electricity because electrons can move through the metal. That's correct. Copper conduct electricity because the electrons in it can move through the metal. Number 4 point. Electrons hold copper's ions together in a lattice by electrostatic attraction. That's correct. Electrons hold copper ions. The electrons are negative, the copper's ions are positive. So the electron holds copper's ions together in a lattice by electrostatic attraction. Positive and negative are attracted together. So point 3 and 4 are correct. So the answer that will correspond to that will be D. Okay? Will be D. So we move to the next question. Question number 8. The equation for combustion of ethane is shown. The equation for the combustion of the ethane is shown. Combustion is burning. It's burning. Like ethane is a fuel. So you burning fuel, like you driving a car. What will it really produce carbon dioxide and water. Combustion will always produce carbon dioxide and water if it's a complete combustion. But if it's an incomplete combustion, it will produce a worse gas, which is carbon monoxide. Carbon monoxide is even worse than carbon dioxide. Okay, but because this is a complete combustion, meaning there is sufficient oxygen. So when there is sufficient oxygen, excess, we call it excess oxygen. In the presence of excess oxygen, the oxygen is in excess. So when you have excess oxygen, there will be a complete combustion. Now that will produce carbon dioxide, which will be released to the atmosphere, and probably can be used by plants also for photosynthesis, and then water will also be produced. So a complete combustion, these are the byproducts, the carbon dioxide and the water. Now which volume of carbon dioxide at room temperature and pressure is formed when 0.5 moles of ethane is burned? Okay, here we're going to use the molar ratio. So here we have for ethane, we have ratio 2, right? We have ratio 2. We're going to compare it with oxygen, which is 7, and we're also going to compare it with carbon dioxide, which is 4, and then we're also going to compare it with water, which is 6. If you bring out the molar ratio, right? Water is 6. Well, I'm looking at the molecule number, that's the meaning of it. So the 2 here, the molecule is this one, and this 7 is this one, this 4 is this 4, and this 6 is this one. Okay, so don't be confused where we are getting these numbers from. Now they've given us the mole of is it which volume? First of all, let's write the volume formula. The volume formula, if you write it in a triangular formula, you remember the triangular formula? Okay, the triangular formula, if you draw the triangular formula, volume V is mole times 24. Mole times 24 dmq. Mole times 24 dmq. So this is the formula we're going to use. The volume is equal to the mole times 24 dmq. Okay, from triangular formula. Remember this formula in the mole calculation, molarity, mole ratio, and all of these things that you learned in chapter 4, chapter 5, chapter 4, chapter 5. Now let's take a look at this today. Which volume of carbon dioxide? So we're calculating the volume of this carbon dioxide. Okay, which volume of carbon dioxide at room temperature and pressure is formed when 0.5 moles of ethane? Now let's see the ethane. The ethane, the mole is 0.5, so I write 0.5 here, other ethane. So if 0.5 is here, if this is 0.5 for ethane, if this is 0.5, for ethane. Now, what will here be? You see, this one, the molar ratio is 2. This one, the molar ratio is 4. So it's like ratio 1 to 2, right? Double. If you double this one, you get 4. You know, this one is for carbon dioxide. This one. Let me draw an arrow to it. This 4 is for carbon dioxide. This 0.5. This 0.5 is for ethane. This 0.5 is for ethane. Okay? So, meaning if we double this one, you get this one. So if I multiply this one by 2, I will get the mole of this one, of carbon dioxide. Why am I multiplying by 2? Because the double of this, double of 2 is 4. Like 2 times 2, if I multiply 2 by 2, I get 4. So I also multiply the mole by 2. So if I multiply this mole by 2, that's 0.5 times 2, I'll get the mole of this one. Because if you multiply this molar ratio by 2, you get this molar ratio. So if you multiply this one by 2, you get the mole of carbon dioxide, which is 1. 0.5 times 2, you get 1. You get 1. You get 1 mole. So the mole of this one is 1. And they're asking us to calculate the volume of this carbon dioxide. So since they ask us to calculate the volume of this carbon dioxide, we're going to say this volume of carbon dioxide is equal to the mole of carbon dioxide, which is 1 times 24. So 1 multiplied by 24, 1 multiplied by 24 will give us the volume. Will give us the volume. Will give us the volume. 1 multiplied by 24, we get the volume. We get the volume. So 1 mole times 24 dm cube will be our volume. But from this volume formula, volume is the mole multiplied by 24. So we get the volume formula. Volume is mole multiplied by the 24 dm cube. That will give us a volume of 24 dm cube. That will give us a volume of 24 dm cube. That will give us a volume of 24 dm cube. Okay? So we go through the option and find if there's any option that has 24 dm cube for carbon dioxide. 24 dm cube for carbon dioxide. A is 48, that's not correct. B is 24 dm cube. C is 12. D. So the answer is B. Is that okay? So we're good to go. We go to the next question. Now the next question says a solution of ethanoic acid CH3COOH has a concentration of 2 mole per dm cube. Which statement about this solution is correct? Which statement about this? So you know, we have to check which one has approximately or close to this either exactly or close to this concentration. Either exactly or close to this concentration. Let's see which one has this concentration. which statement about this solution is correct? Now 20 gram of ethanoic acid. First of all, we have to calculate the molecular mass or the molar mass of ethanoic acid. We have to calculate the molecular mass of ethanoic acid because we have to calculate the number of mole of each one. Number of mole, you can use triangular formula like the one just now to calculate the number of mole. Number of mole is equal to mass in gram. Number of mole is equal to mass in gram times molar mass. Number of mole is equal to mass in gram times molar mass. Okay. Number, we can use sorry. Number of mole, yes, mass in gram divided by molar mass. Okay, it's a slip of tongue. Okay, we say, see, I'm going to show it in a triangle. I'm going to show it in a triangle. There's no arrow. Okay, let's delete it. There's actually no arrow. It's just a line. And to make formula. Okay, number of mole. Here I write mole. M-O-L. Mole is the mass. So I just write M here. Mass in gram over M arrow. Molecular mass or molar mass, whatever you want to write. M with subscript arrow. Okay, so for each one we calculate their mole. It's when you know the mole before you can do the concentration. It's when you know mole you can do concentration. Concentration, you can do another triangle. All these things you must remember. Honestly, no joke. You have to remember. If you don't remember this small formula, you will struggle in the exam. So I'm just reminding you. Use this opportunity to remember. Okay? We're doing it with you now. Use the opportunity to remember. Concentration. Concentration. So conc. I write conc, abbreviation conc. Concentration is the mole divided by volume. Mole divided by the volume. Volume in dm cube. Mole divided by volume in dm cube. If they give you centimeter cube, you want dm cube. You know, in chemistry we usually put the unit in dm cube. If they give you centimeter cube and you want dm cube, if they give you centimeter cube, you want dm cube. Let's say they give you 250 centimeter cube, and you know in most calculations we have to put them in dm cube. What do? You divide by 1000. If you want to change centimeter cube to dm cube, you divide by 1000. Divide by 1000. So once you divide by 1000, you get your dm cube, your volume in dm cube. Is that okay? So this one as a reminder, take it as a reminder. Divide by 1000, you get your volume in dm cube. Okay, so each of this one, it has its own mass. 20 grams of ethanoic acid. First of all, let's calculate how many carbon do we have in ethanoic acid? 2 carbon. Right? We have 2 carbon, and carbon is 12. So we can say 12 times 2. 12 times 2. 12 times 2. We want to find the molar mass or the molecular mass. So you say plus 12 times 2 plus. Then the next one is hydrogen. How many hydrogen? Altogether there are 4 hydrogens. You don't just say 1 times 3. Hydrogen, the mass is 1. So, and there are 4 hydrogens altogether. 3 here, 1 here. Altogether 4. So I will say 1 times 4. 1 times 4. 1 times 4. Then I bracket. Then the next one is oxygen. How many oxygen I have? How many oxygen atom I have? I have 2. So I say oxygen is 16, right? So I'll say 6 plus 16 times 2. Plus 16 plus 16 times 2. Okay, here is too small. I think we delete. We go to another line. Plus 16 times 2. 16. Oxygen is 16, right? So we say plus 16 times 2. Okay, now we add everything together, molecular mass. So 12 times 2 is 24. So we're going to have 24 plus 1 times 4 is 4 plus 4 plus 4 then plus 32. Times so plus 32. Plus 32. So 32 plus 4 is 36. 36 plus 24. 36 plus 24. Plus 24. If you add them together, what do you get? 0. That's 60. We get 60, right? The molecular mass, MR, is 60 of this compound. Is 60. So, you know, the concentration, the mole is the mass divided by the molecular mass. So, 20 divided by 60, we test A, and then we divide by the volume that they gave to us, and see whether we get 2 mole per dm cube. (20 divided by 60) to get the mole for A, it will be 20 divided by 60. 20 divided by 60 for A. You get 1/3, right? And then you divide by, you see this volume? We change it to decimeter. 10 divided by 1000, that would be 0.01, right? 10 divided by 1000 divided by 1000, we get 0.01. So 0.33, we got 0.33 just now, right? 0.33 divided by 0.01. 0.33 divided by 0.01. 0.01. You get 33. So this one is wrong. So this cannot be the answer. 33 mole per dm cube cannot be the answer. We go for B. Now 30 grams divided by 60. You get 30 divided by 60, you get 0.2. To get the mole, you get 0.5. 30 divided by 60. Now divide by 0.25. 0.5 divided by 0.25. Because we have to change this one to decimeter cube. 2. So this one is the answer. B is the answer. You know why? See, first of all, the mass in gram, the mass is 30 grams. So you say 30 grams. Let me solve. Since it's the correct answer, let me solve it out. So you say 30 grams. 30 grams divide by the molecular mass, which is 60. So if we divide it by the molecular mass, which is 60, we'll get 0.5 mole. This will give us 0.5 mole, right? This will be equal to 0.5. That's half. 0.5. This will give us 0.5 mole. Now, since we are looking for concentration, concentration is mole divided by volume. And the volume they gave here is 250 centimeter cube. So we change it to decimeter cube. So I wrote it out before. 250 divided by 1000, you get 0.25, right? You get the volume will give you 0.25 in decimeter. You get 0.25. So we get 0.25. This is our volume. This is the volume that is given in B. 25 centimeter cube divided by 1000, you get 0.25 decimeter cube. Now to find concentration, you say this 0.5 divided by 0.25. To find concentration, because concentration is mole divided by dmq. Look at the concentration is mole divided by volume. So our mole is 0.5. So we say 0.5 So we say concentration conc is 0.5 divided by 0.25. 0.25. So if you divide this 0.5 divided by 0.25, you get 2 mole per dm cube. 2 mole. Your answer will be 2 mole per dm cube. 2 mole per dm cube. The answer will be 2 mole per dm cube. Which is this one that was given. So the one that will give that answer is B. So we choose B. It's not really long anyway. It's just the way the board is so slow to write on the paper, so slow. Like first of all, you calculate the mole by saying mass divided by the molecular mass. We calculate the molecular mass, we get 60 grams. So this 30 gram mass divided by 60, you get 0.5. Then to get concentration, you say the mole 0.5 divided by the volume. The volume that is given. The volume is given in centimeter cube. I say anytime they give you in centimeter cube, divide by 1000 to put in decimeter cube. Like this one is already in decimeter cube and this one is already in decimeter cube. You don't need to do anything about this volume. But these ones are not correct. Even if you do this, will be 60 divided by 60, you get 1 mole. Okay, to do this one, the mass is 60, the molecular mass is 60. 60 divided by 60, you get 1. 1 divided by 1, you get 1. So the volume of this one is 1 mole per dm cube. So this one is wrong. C is wrong. If you want to try this one, it will be 120 divided by 60, you get 2. 2 divided by 2, you get 1. Also 1 mole per dm cube. Doesn't correspond to this 2 mole per dm cube. So you can check for all and you see B is the most correct answer. We go to question number 10. Okay, we go to question number 10. Question number 10. We say aqueous copper 2 sulfate is electrolyzed using copper electrode. Which statement is correct? Is electrolyzed using copper electrode. Which statement is correct? A reduction reaction occur at the positive electrode. Not really. The blue color of the solution becomes darker. Not really. The concentration of the copper ion in the solution decreases. The concentration of copper ion in the solution, no. The mass of the negative electrode increases, yes. The mass of because the negative electrode will be melted, like it will be melted, because you're doing concentration of copper sulfate and you're using copper as electrode. The copper at the negative electrode will begin to melt. Will begin to will begin to add up. Will begin to swell up. Because the copper ions from the solution will migrate to the negative. The positive copper ion will migrate to the negative electrode, and they will add up. So the mass will get bigger. The mass of the negative electrode will get bigger because this copper ion from the electrolyte will migrate and add up to the negative electrode. So D is the answer. Is that okay? We move to this question. It says dilute sulfuric acid is electrolyzed using inert electrode. Dilute sulfuric acid is electrolyzed using inert electrode. Okay, we're looking at sulfuric acid, right? So you have to go back to electrolysis, and we are using some inert electrode. Could be carbon, could be copper. What are the ionic half equations for the reactions that take place in each electrode? Okay, at the positive you cannot have a positive reaction taking place at the positive electrode. So A and B, they are wrong. A and B, they are what? They are wrong. A and B, they are what? They are wrong. Why? Why is that so? Because these are the logic in writing exam. You have positive electrode. You cannot have a positive reaction taking place. Okay? Hydrogen is positive. It cannot be taking place in the positive electrode because the positive ion will migrate to the negative electrode. That's the rule in electrolysis. From the electrolyte, the positive ion will migrate to the negative electrode, and the negative ion will migrate to the positive electrode. So negative cannot be on the negative, positive cannot be on the positive. So A and B completely out of place. They just squeezed you. So your best bet is C and D. So you reduce your problem by narrowing down your choices. And so we're going to look at the C and D. C, the hydroxide ion electrolyzes to form water, oxygen, and 4 ion. Yes. And let's take the other side. This is what's happening on the positive side. On the negative side, the hydrogen ion goes through electrons to become hydrogen gas. Loses 2 electrons to become hydrogen gas. Yes. So this is our correct answer. This is what is happening in the electrolysis of sulfuric acid. Okay? This is what is happening. Remember, in the electrolysis of sulfuric acid is H2SO4. Okay? H2SO4, okay? Sulfuric acid is H2SO4. H2SO4. This is sulfuric acid. Okay? This one produces the OH ion because it produces OH ion, it produces hydrogen ion. The OH ion migrates to the negative electrode, and the hydrogen ion migrates to the OH ion migrates to the positive electrode, and the hydrogen ion migrates to the positive electrode. Okay, the OH ion is from the water. Okay, the OH ion is from the water, not from the SO4, and the hydrogen arrives from here. Okay, from here, from the water. So they migrate to the negative electrode. And so this is what is happening in this regard. Now let's move to the next question. Plant cells use energy from sunlight for photosynthesis. Plant cells use energy from the sunlight for photosynthesis. Which role describe and explain the energy change that occurs? Plant cells, okay, first of all, plant cells is taking oxygen. So this is going to be endothermic reaction, endothermic reaction, not exo, because they take in the oxygen, right? Then they take in the energy. They do not give up. So the answer is going to lie between A and B. So we say endothermic. The explanation is that less energy is released, making bond that it's absorbed to break bond. I think that looks very correct. And then let's see the B. More energy is released. No, if you release more energy, it becomes exo. More energy is released, making bonds that is absorbed to break bond. No, I think the answer is A. Because if you release more energy, you're automatically becoming exothermic reaction. Okay, so we go for A. Now we go to the next question. This one is also a calculation. You need to know energy change. You need to know how to calculate the energy change in chemical reaction. So to do this, we look at the equation, then we'll be able to do something, right? We say hydrogen bromide decomposes to form hydrogen and bromine. You know, decomposition is when there's a decomposition, that's an endothermic reaction. Any decomposition reaction is an endothermic reaction. So this is going to be an endothermic reaction, which means the energy change is going to be positive. So when we calculate the energy change, we're outrightly going to get a positive kilojoule per mole. The energy change that we're going to find in this regard has to be a positive number. So if you get a negative number, then something is wrong with your calculation. Okay? Because it's an endothermic reaction. Why is it endothermic? Because it's a thermal decomposition reaction. All thermal decompositions are endothermic reaction. Is that okay? So we say hydrogen bromide decomposes to form hydrogen and bromine. Now the equation is shown. Now let's take a look at this. This hydrogen bromide is a gas. It decomposes to form hydrogen gas and bromine gas. Now the bond energies are shown in the table. And the reaction is endothermic. Oh, they even mentioned it. So even if I didn't say that, they've already mentioned it for you. The reaction is endothermic, but you already know because it's a decomposition reaction. The reaction is endothermic. So the bond energies are given. Bromine to bromine, single bond is plus 193. And hydrogen to bromine, single bond is plus 366. And hydrogen to hydrogen is plus 436. Now, we're going to calculate the energy change. First of all, before you can do the energy change, let's do the bonding characterization or the bonding characteristics. Let's do the bonding characteristics. I hope this board, this place, we can write that here. Okay, so we have the hydrogen. I will do the bond formation, okay? The way it's be bonded. Hydrogen we bond with bromine. We bond with bromine. Bromine is Br. Okay? And in this bonding, there are two molecules of it. So I'm going to multiply with 2. I'm going to multiply this with 2. If I don't have space on the left, I put the 2 on the right. Okay, maybe we can still put it here. We're going to multiply it with 2. Okay, so we see, we have these 2 here. Oh, the 2 is, okay. We have these 2 here. Is that okay? And then, this is the energy that is required to break this bond. You know, you have to break this bond in order to form new bonds. If you don't break this bond, you cannot form the new bond. So energy required to break the bond is called the energy in. So energy change that we are looking for, let's write the formula. Energy change, the energy change is equal to the energy in That's energy taken in to break the old bond, which is the hydrogen bromide gas. Energy taken in to break the old bond is called the energy in. Energy taken in to break the old bond is actually energy for, this energy in is usually energy for breaking bond. Is usually energy for breaking bond. Because you have to break the old bond before you can form new bond. So we say energy in minus energy out. Minus energy out. Energy out is the energy for forming the new bond. The hydrogen gas that is formed and the bromine gas that is formed. Energy out is same as the energy for, energy out is same as energy out is the energy that is used for forming the new bond. Energy in is the energy for breaking the old bond. Like the energy of reactor, to break the reactor to form the product. The product is the energy out, which is the energy for forming new bond. The products are the new bonds. The reactors were the old bond that needs to be broken. Okay, so this one is equal to, we draw an arrow. Now what's the bond here? Hydrogen to hydrogen. This one does not have two molecules at the back, so we're not going to multiply by 2. We just do one hydrogen to another hydrogen. That's what we're going to do. One hydrogen to another hydrogen. One hydrogen bond to another hydrogen bond. To another hydrogen bond. Okay? There is no multiplication. You are not multiplying with anything. Because there are 2 atoms of hydrogen. One atom and another atom, finish. You are not multiplying with any number because there is no number here. If there is 3 here, we would have multiplied with 3. Okay? There is no number, so we're not going to. There are 2 atoms. This one atom, this is the second atom. Okay? Then plus that of bromine, same thing. You do say plus that of bromine. Plus bromine to bromine, single bond. Bromine, Br, to another bromine single bond. So we are not going to multiply with any number, like it's just multiply with 1. You're not going to multiply with any other number, okay, because it's just 2 atoms. So here we just go. So this is called energy in. This one is energy in. Energy in. This is called the energy in. And these 2, they are called the energy out. These 2, they are called the energy out. Energy out. Energy out. Energy for forming new product or new bonds is called the energy out. But these 2. Okay, now let's calculate. And to get the energy change, we can say what is the energy change for the reaction? You see? What is the energy change for the reaction? To calculate the energy change, we have to calculate the energy in first. What is the energy in? You go here, you come to the table. Hydrogen to bromine bond is 366. So we're going to say 366 times 2. Why are we times it by 2? 366 times 2. Why? Why are we multiplying by 2? Because of these 2 outside. You can see these 2, right? These 2 molecules. These 2. Okay? These 2 molecules. molecules of it. So we're going to multiply here by 2. 3, 6 to get our energy in. To get our energy in. So we times this one by 2. You can put the times 2 anywhere, either in front or at the back. Times 2. So this is our E, energy in. Energy in equal to okay, this times 2. 366 times 2, what do you get? 732, right? We get 732. So we keep our energy in 732. 732. So that's our energy in kilojoule per mole. Okay. So we get our 732. Now let's do our energy out. Energy out. Energy out is equal to now you come, what's the hydrogen to hydrogen single bond is what? 436. So you write 436 plus, because you're not going to multiply with anything, it's just single. Okay, plus bromine to bromine single bond. What's bromine to bromine? Bromine to bromine is 193. So you say plus 193. Plus 193. So add. Let's add. This will be equal to what? Energy out will be equal to what? What do you get? We get 629, right? 629. That's the energy out. And then what they ask us to calculate is energy change, which is delta energy. Delta energy, which is energy change, is equal to energy in minus energy out. Energy in energy in minus energy out. Minus energy out. Okay, so our energy is 732, right? So you say 732. 732 minus what? 629. Minus 629. So we get what? We get 103. So plus 103, positive number. So 103 means plus 103. But if it's a negative number, you would have got a negative. 103. Okay, so we go check which answer has that. B, right? take much to do actually. It's because we are writing a slow board. Okay, so the answer is B. Now we go to the next question quickly. Which rule describes the effect of increasing both concentrations and temperature on the collision which rule describes the effect of increasing both concentration and temperature on the collision between the reactive particles? Okay, on the collision between, so increasing concentration, more collision per second only. On increasing temperature, more collision per second only. No, when you increase temperature, it's not only collision per second only. Other things will be involved. Energy, thermal energy will increase. Okay, B, more collision per second and more collision per second and more collision with sufficient energy to react. This one would have been suitable for energy, for temperature, increasing temperature. And the B is a more collision per second only for temperature. No. So they swap this B. And then C, more collision per second only for increasing concentration and more collision per second and more collision with sufficient energy to react. C looks correct. Yes, C is the correct answer. D, because D is both of them. So which is not so. C is our correct answer. So the questions we can move fast. Let's try to move fast. Is it the formation of sulfur trioxide is a reversible reaction? Of course. This is used for the production of sulfuric acid. It's part of the process of making sulfuric acid. Okay, here you make sulfur trioxide first, which will now be used to make sulfur and then H will now react with hydrogen, you get H2SO4. So the process of making sulfuric acid, a reversible part of it is sulfur dioxide react with oxygen gas, produce sulfur trioxide. The forward reaction is exothermic, of course, and the backward will be endo because it will be a decomposition. The backward reaction will be like you are decomposing this to get oxygen and sulfur dioxide, so it will be endo. But the forward is exo because you are burning, you are reacting with oxygen. So it releases a lot of energy. So that's that. Now, which condition produce the highest equilibrium yield of sulfur trioxide? Which one will give us the highest yield of sulfur? Since it's a reversible reaction, which one will give us the highest yield of this? That means here, if you have highest yield, I think you can increase pressure, but you have to reduce temperature. Because if the temperature is too high, the rate of forward reaction will be equilibrium point will be reached, and the rate of forward reaction will be the rate of backward reaction. So as you are getting sulfur trioxide, they are immediately going back to sulfur dioxide and oxygen. So I think we increase make pressure high and make temperature low. Okay, this is always a factor if you want to maximize it for a reversible reaction. You keep the temperature low. It's one of the factors. You can refer to your textbook. Now we move on to this one. Chlorine displaces iodide ions from potassium iodide. Okay, here chlorine, this potassium iodide actually, but it was just it was not show complete. Okay, they just like half equation something. Chlorine displaces iodide ion from potassium iodide to produce iodine and chloride, potassium chloride. What is the oxidizing agent? Of course, chlorine. Chlorine is the oxidizing agent because it gets itself reduced. Okay, so the oxidizing agent will be chlorine, right? Oxidizing agent will be chlorine. Yes. Because it gets itself reduced to ion, chloride, potassium chloride ion. Okay, now which statement about oxides is correct? Oxides. Okay, we have basic oxides. These ones, the ones that are formed by metals. We have acidic oxide, the ones that are formed by non-metals. That's when non-metals we have with oxygen, like SO2. Okay, they are acidic oxide. We have amphoteric oxide, like aluminium oxide, and then we have the one that can act as acid and also act as acidic oxide and also as basic oxide. And then we have neutral oxide, the ones that are like nitrogen dioxide, nitrogen monoxide, nitrogen dioxide. Okay, those ones are neutral oxide. a brief overview of oxide. They say which statement about oxide is correct? A solution of magnesium oxide has a pH. Magnesium oxide is a basic oxide, right? It has a pH less than 7. That's wrong. Because pH less than 7, the acidic oxide is supposed to be an acidic oxide. So if you are a basic oxide, you cannot have a pH less than 7. Your pH will be from 8 to 14. Your pH will be from 8 to 14. Now B, a solution of sulfur dioxide has a pH greater than 7. Sulfur dioxide cannot be greater than 7. Sulfur dioxide is an acidic oxide. Its pH is supposed to be from 1 to 6. So this one is also wrong. Then the magnesium oxide react with nitric acid to form salt. Magnesium oxide react with nitric acid to form salt. Sulfur dioxide react with hydrochloric acid to form salt. Magnesium oxide will react with nitric acid to form salt. I think that's more appropriate. Okay? Yeah, because metal oxide they react with acid to produce salt. Metal oxide, not metal oxide don't do that. No metal oxide doesn't do that. You know why? Because metal is higher than hydrogen. Okay? If you want me to write the equation, magnesium oxide, we can write the equation so that you understand what we are saying. Magnesium oxide, MgO. Magnesium oxide react with nitric acid HNO3. Nitric acid react with nitric HNO3. React with HNO3. This is a nitric acid. Okay, magnesium oxide react with nitric acid to produce, because this magnesium is higher than hydrogen, it will displace this hydrogen. We will tell this hydrogen to stand up. Okay, because it's higher in the reactivity series, so it will form magnesium nitrate. To form magnesium nitrate. Which is a salt. To form magnesium nitrate. To form magnesium nitrate. I think there's 2 here. To form magnesium nitrate. Okay, so this is a salt. This is magnesium nitrate plus water. Okay, plus water. Why water? Why plus water? Because this hydrogen will combine with oxygen here to form water. Plus water. Hydrogen will react with oxygen. Okay, to form water. You can balance the equation. Okay, I'm not after the balance, I'm just showing you what is happening. Okay, so this is what is happening. This is a salt. This one is a salt. Salt and water is produced when metal oxide react with the acid. It could be metal oxide or metal hydroxide. If it's metal hydroxide, it's a neutralization reaction, meaning an alkali react with an acid to produce salt and water. That's a neutralization reaction. But when metal oxide reacts with acid, they form salt and water also. They form salt. Okay, salt and water. Okay, so that's what's taking place. So C is the correct answer here. It cannot be sulfur dioxide. Sulfur is not even in the reactivity series. It's not a metal. So it cannot displace hydrogen in this regard. Hydrogen is a super boss. Okay, you join the big boys. Even though it's not a metal, it behave like a metal. Okay, you join the super big boy. You can do kitty. Okay, hydrogen can follow the kitty hustling. Okay, so you join the big boys. Okay, so question 18, which solution has the lowest pH? Which solution has the lowest pH? Lowest pH is the one that is acidic. Okay, acid have low pH, right? Acid has lower pH. So A is wrong. Ammonia is not acid. B, ethanoic acid is a weak acid. It may not have the lowest one. The lowest one is a concentrated acid. Lithium hydroxide. This one is not an acid. It's an alkali. And then the nitric acid. Yes, this one will be our answer. 0.1 mole of nitric acid. Okay, because nitric acid is oboge acid. Okay, now let's move on. Okay, I'm using some snacks. If you don't understand, it's okay. It means the correct one is the correct one. Now let's take a look at this. A student mixes silver nitrate and barium chloride to form a white precipitate of silver chloride. The equation is shown. So a student took silver nitrate, reacted with barium chloride to produce silver chloride and barium nitrate. All of these are salts. We are reacting two soluble salts to produce one soluble and one insoluble salt. So this one is a soluble salt. Silver nitrate is a soluble salt. You can go and check your books. Okay, for those who study, they understand. This one is a soluble salt, silver nitrate. Barium chloride is a soluble salt. Silver chloride is a soluble salt, and barium nitrate is also a soluble salt. So this method is using two soluble salts to produce one insoluble and one soluble. So here they've categorized them to soluble and insoluble. So let's find the insoluble. I think there's only one insoluble salt, this one. So we go and look for insoluble column. The one that has silver chloride, only silver chloride, other insoluble might just be the right answer. So insoluble, we go to insoluble, we look for silver chloride, this one. So let's check the other side if the answer could be correct. We check here. For the soluble, silver nitrate, this one is soluble. Barium chloride is soluble. And barium nitrate is soluble. So our answer will be C. Our answer will be C. Is that okay? Okay, so you must note the salts that are soluble and the ones that are insoluble in water. Okay? Okay, now let's move on to the next question. Which methods are suitable for preparing both zinc sulfate? Which methods are suitable for preparing both zinc sulfate and copper sulfate? Copper is lower than hydrogen in the reactivity series, so we cannot use the same method we use for zinc sulfate to prepare the salt zinc sulfate, and as the same method for this one. If you want to prepare the salt of copper through sulfate, you cannot say the oxide zinc oxide react with the sulfuric acid. That will only work for this. You cannot say copper oxide react with sulfuric acid, but you can do zinc oxide react with sulfuric acid to produce zinc sulfate. Okay, so here you're going to do what we call maybe copper carbon. You're going to do a carbonate reaction, like maybe copper carbonate. You're going to do a thermal decomposition of copper carbonate for this one. Why are we using this method for this one? Because copper is lower than hydrogen in the reactivity series, and you remember the sulfuric acid has hydrogen, so we're looking for what can displace this one, right? Sulfuric acid is H2SO4. Sulfuric acid is H2SO4. When it reacts with zinc oxide, it will produce zinc sulfate and water. If it reacts with zinc oxide, if this one reacts with zinc oxide, it will produce zinc sulfate and water. If it reacts with zinc oxide, it will produce when this one reacts with this zinc, we form zinc sulfate. So this zinc will displace this hydrogen because zinc is higher in reactivity series. Zinc is higher than hydrogen in the reactivity series. So you have to check your reactivity series. So zinc will displace hydrogen to produce zinc sulfate. It will be ZnSO4. This will be the salt. But we cannot do the same. We cannot say copper oxide react with this one, because copper cannot displace hydrogen. Copper and silver, they're below hydrogen in the reactivity series. So we cannot do the same for when we are preparing copper 2 sulfate. To prepare copper 2 sulfate, you have to decompose copper carbonate to produce copper oxide, carbon dioxide to produce copper. okay, copper sulfate. Okay, you have to decompose copper sulfate. Okay, so let's take a look at the options. Reacting the metal oxide with warm dilute aqueous sulfuric acid. This one, metal oxide like zinc oxide. Okay, reacting the metal oxide with warm dilute aqueous. Okay, this one, I think this point is valid because it will work for zinc sulfate. B, reacting the metal with dilute aqueous sulfuric acid. No, reacting the metal carbonate like copper carbonate with dilute aqueous sulfuric acid. Okay, this one has to react with aqueous sulfuric acid. Okay, this one will react with aqueous sulfuric acid. So in order for us to produce sulfuric acid is H2SO4. It's H2SO4. H2SO4. Okay, so this react together, you can get the salt, copper sulfate. You can get copper 2 sulfate plus water plus carbon dioxide. If this one react together, you're going to get this copper 2 sulfate plus this one will break, you get CO2, and then one oxygen will leave, react with this H2 to form water, and you get carbon dioxide. Okay, so this one is also valid. Why is this method? Why do we have to take copper carbonate to react with sulfuric acid? Because it cannot, copper oxide cannot displace, copper cannot displace this one. Okay, this one will first of all break. Is that okay? And then react with the sulfate of this one, and then carbon dioxide will be produced and water will be produced. So the answer will be the one that has 0.1 and 0.3. The one that has 0.1 and 0.3 will be our most correct answer. We hope so. 1 and C. Yeah, that's C, right? That's C, right? Yeah. So we move on to the next one. Is it which element is in the same period of the periodic table as silicon? This one you have to open your periodic table. So as at the back of your exam paper, you have to check your periodic table. Okay, which one is in the same period as silicon? You know, silicon's atomic number is 14. Okay, so if atomic number is 14, we have 2, 8, 4. Your last electron is determines your group in the periodic table. So also is in group 4, but we are looking for period. Period is the number of shares you have. If you have 3 shares, so which one also have 3 shares here? Among all these elements, sodium has 3 shares. 281 has 3 shares. Sodium has 3 shares. The first share holds a maximum number of 2, second share 8, the third one holds 1 for sodium. So for the same period will be sodium. You can check your periodic table for this. Okay, scandium, they are in higher. Germanium is in another period, but they are is in the same group with silicon, but is in another period. Okay, period is the horizontal arrangement, while group is the vertical arrangement. So you must not get confused. Which statement about the halogen is correct? Which statement about the halogens is correct? A sample of bromine react with potassium chloride. Can bromine displace chlorine? No, because chlorine is higher than bromine, so it's not correct for halogen family. Halogen, the first one is fluorine, second one is chlorine, third one is bromine, fourth one is iodine, fifth one is astatine, and like that till you get to the end. Okay, so bromine cannot displace chlorine from potassium chloride, so this one will be wrong. Second one, a sample of bromine react with potassium iodide solution. Yes, This one looks correct. You know why? Because bromine is higher than iodine. So bromine can display iodine to form potassium chloride, potassium bromide, while iodine will be released. Okay? A sample of chlorine has a higher density than a sample of bromine. No? A sample of chlorine is darker colored than a sample of bromine. I think the answer will be B. A sample of bromine can react with, so a sample of bromine react with the potassium iodide. Why? Because bromine is higher than iodine, so it can displace iodine. So this will form potassium bromide plus iodine. Okay, so the higher one can only displace the lower one. Now let's move on. Now it says, which role shows the catalytic activity of transition element and their compound? You know transition element, right? They are used as catalysts. Even as element, also as compound, they are good catalysts. So I think the answer is A. Because the catalytic activities of transition element, they are good as catalysts for element, and even as compound, they are also good. So the answer will be A. Remove. Questions like this, you use it to speed up. Now the following statements are made about the metal copper, metals, copper, iron, magnesium, zinc. The oxides are acidic. The oxides are acidic? No, the oxides are not acidic. For copper, for metals, the oxides are basic. They all conduct electricity in solid state. Yeah, they conduct electricity, right? They all have high melting point. Yes, metals have high melting point. They all react with dilute acid to form hydrogen. Yeah, right? No, not all of them. Not all of them. Okay. So I think the one that we are sure they are very correct, 0.2, 0.3, they are 100% correct. So anyone has 0.2 and 3? Yes, C. Okay, so C will be the answer. Because these ones, they don't form, oxides are not acidic, the oxides are basic. Only non-metal form acidic oxide, like sulfur. Sulfur form acidic oxides. Metals, they form basic oxides. They don't form acidic oxides. Then we say metal, they all conduct electricity solid state, yes, because they have delocalized electrons. They have delocalized free mobile electrons. And they all have high melting points. Yes, metals, because they have high density, so they have high melting points. And because they are also hard. Okay, so we go for that. Now we go to 25. Silver is less reactive metal than cadmium. Cadmium is less reactive than barium. Okay, silver is less reactive than cadmium. So let's say if silver is here, silver Ag is less reactive than cadmium. So cadmium is here. And the cadmium itself is less reactive than barium. So barium is here. So barium is more reactive, followed by this. Now which statement is correct? Barium does not react when heated with silver oxide. If barium is, which statement is correct? Barium does not react with when heated, no, it will react. So this one is not correct. Because barium is higher. If you react with silver oxide, because it's higher than silver. So it's that they say does not make it wrong, because it actually reacts. Cadmium displaces barium. Cadmium cannot displace barium because cadmium is less in this reactivity series for these three elements. Cadmium is less than barium. So cadmium cannot displace barium from a solution of barium chloride. Cadmium displaces silver. Yes, cadmium can displace silver. Cadmium displaces silver from a solution of silver nitrate. Yes. Cadmium reacts when heated with barium. Cadmium cannot react when heated with barium oxide. Okay, I think the correct answer will be C. right? The most correct answer will be C, because cadmium can displace. Look at cadmium, it's higher than silver. Silver is less. It's like this in their reactivity series. Let's say we draw the arrow. See, barium is higher than cadmium in reactivity series. Cadmium is higher than silver. So it means cadmium can displace silver from a solution of silver nitrate. When you have silver nitrate, cadmium can displace the silver and form cadmium nitrate. So we go to the next question. Is that okay? Aluminum metal is extracted from aluminum oxide using electrolysis. Which statement about the extraction process is not correct? Which one is not correct? Means all the rest are correct except one, right? Which statement is not correct? Now let's take a look at them. You say a large amount of electricity is required. That's correct, right? We're looking for the one that is not correct. Because when you do electrolysis, you need the electricity. Use it by using a battery. Number 2, multi-cryolite is used to dissolve the aluminum oxide. That's correct. That statement is correct. We use multi-cryolite to dissolve the aluminum oxide. Okay, we should call the bauxite. So that's correct. We're looking for the one that is incorrect. Oxygen gas is released, which react to form carbon dioxide. Yes, that is correct in this electrolysis process. Oxygen gas is released and it reacts to form carbon dioxide. That's correct. The negative electron burns away and have to be replaced. This is incorrect, right? So we go for the incorrect answer, D. So move to the next one. Questions that are sharp and simple, we move fast. Which statement explains why aluminum is used in the manufacture of aircraft? Why do we use it? Because it conducts heat? No. Is that why we use it to manufacture airplanes and all other aircraft? It has low density? Yes. It's a good conductor of is it because it's a good conductor of electricity? No. It's easy to recycle? No. Because it has low density. I think this is the most superior answer. So we go to question 28. It's a dry air is passed over hot copper until all the oxygen is reacted. Dry air is passed over hot copper until all the oxygen is reacted. So we have dry air here, copper is here. You see this copper is heated. Dry air is passed over hot copper until all the oxygen has reacted. Dry air is passed over hot copper until all the oxygen has reacted. So here we supply dry air. This copper is heated, it's very hot. Then the oxygen in the dry air must have reacted. The volume of gas at the end of the reaction is 120. The volume of gas at the end of the reaction is 120. What is the starting volume of the dry air? What's the starting volume? The starting volume will definitely be more than 120. Okay, because the volume of the gas at the end of the reaction is 120. Okay, so A 132, B 152, C 180. I think we go for 152. 180 is big. 152 is too low compared to 120 we get at the end of it, and 180 is a bit too high, and this one is absolutely too high. So we go for 152. So 152 as the volume of the dry air. When it's used to cool this copper, the volume we get out toward here is 120. So 152 was fed in as the volume. Some few ones were lost in cooling the copper. Is that okay? So that's that for that. We move to the next question. This question is just a logical question. It's not like you go to calculate. Now a steel bicycle which had been left outdoors for several months was starting to rust. You left a steel bicycle outside outside door for several months, meaning rabbit seeds, air passes through it. Oxygen and the water, they are agents of rusting. So it started to rust. What would not reduce the rate of corrosion? What would not reduce the rate of corrosion? What will not reduce it? Remove the rust and paint the bicycle. Yes, this will reduce it, right? Remove the rust and store the bicycle in a dry shade. Yes, this will reduce it. Remove the rust and wipe the bicycle with a clean damp cloth. No, if you wipe it with a clean damp cloth, it will rust more. Remove the rust, it will rust again. Remove the rust and wipe the bicycle with an oily cloth. Yes, this will help it. They are asking what will not help it. This one. If you put a damp cloth on it, it will not help it. Okay, now let's take a look at question 30. Which statements about water are correct? Which statement about water is correct? About water is correct. Now, household water contains dissolved salt. Yes. Household water contains dissolved salt. So we can take this point. Water for household use is filtered to remove soluble impurity. We don't normally do this, right? Then we say water is treated with chlorine to kill bacteria. Yes. Water is used in the industry for cooling. Yes. We use water in the industry for cooling, right? Water is used in the industry for cooling. Right? So, any point we have 1, 3, and 4. 1, 2, 3, 1, 3, 4. Okay, see. I think this one is our most best bet. Okay, so we go for that option. Now let's go to 31. We don't have time. This question, 31, comes in every exam paper. Most of the years you see this question. It's about a herbal process, manufacture of ammonia. Okay, they want to ask you about the source of the hydrogen. The hydrogen is from hydrocarbon, what we call the natural gas. So, source of hydrogen is this one. So, A and B, they are already wrong. A and B are already wrong, okay? A and B, they are already wrong. So, you choose the answer from C and D. Because the hydrogen is from hydrocarbon, the natural gas. And the nitrogen is from the air. And the temperature is 450. And the atmospheric pressure is 200, not 2. So the answer is D. Most of the years this question is there. So they keep repeating it. So get used to it, okay? You find it in your exam as well. Now let's take a look at 32. Which statements about carbon cycle are correct? Carbon dioxide is added to the atmosphere by respiration. Yes. When we breathe, we release carbon dioxide to the atmosphere. So we take this point. Carbon dioxide is added to the atmosphere by combustion of coal. Yes. When we burn coal, combustion. When you burn coal, you release carbon dioxide to the atmosphere. Yes. Carbon dioxide is removed from the atmosphere by photosynthesis. Yes. During photosynthesis, the carbon dioxide in the air is taken to the leaf, okay, through the stomata. So 1, 2, 3. Do we have any option? 1, 2, 3? A, right? Yeah, so that's our answer. So we go for A. Now we move to question 33. Which statement about sulfur and its compound is not correct? Which statement about sulfur and its compound is not correct? Okay, sulfur dioxide is used as a food preservative. Do we do that? Yes, right? It's not correct. We are looking for the one that is not correct. So you must be careful with this not correct type of question. They make people fail a lot. You'll be looking for the correct one. You don't know they are asking you for the one that is not correct. Sometimes you forget. So in the exam, use your pen to highlight this place. say which statement about sulfur and its compound is not correct. So anyone that is correct. Sulfur dioxide, is it used as food preservative? No. Sulfur is a greenhouse gas. Sulfur dioxide is a greenhouse gas. You use it to preserve food? No. Sulfur dioxide turns acidify aqueous potassium manganese 7 from purple to colorless. Yes. So we are looking for the one that is not correct. This is not the answer. The one that is correct, they will be the wrong answer in this regard. So be careful. So sulfur form a basic. Sulfur form basic oxide. No. Sulfur form acidic oxide, right? Sulfur do not form basic oxide. Okay, I found another one that is superior to A. That means sulfur dioxide can actually be used as food preservative, because there is no way in this life for now, as far as research is concerned, where sulfur will form a basic oxide. Sulfur they form acidic oxide. So this one is more superior. So you see, even if you were not sure about this, I almost went for A. But even if I was not too sure if it was used as a preservative, if I couldn't remember, but I found a superior argument. So since you found a superior argument, so A can no longer stand, C will stand. Sulfur is used in the manufacture of sulfuric acid. Yes. So we already know this absolutely. They are looking for the one that is wrong. So the most wrong answer is C. The most wrong answer is C. You see how you can use what your options. That's why it's good to read all the options. So even if you are not too sure if sulfur dioxide was used as food preservative, you found a more wrong answer, which because they asked you to pick the wrong one as the correct answer. So this is a more superior one. We go to 34. Which process is used to convert limestone calcium carbonate into lime? Is it electrolysis? Is it fractional distillation? Is it incomplete combustion? Is it thermal decomposition? I go for thermal decomposition. Thermal decomposition is calcium carbonate, CaCO3, CaCO3. When heated, we decompose to form calcium oxide, which is lime. Decompose to form calcium oxide. Calcium oxide plus carbon dioxide plus carbon dioxide. So when they ask us which process, we say thermal decomposition. Okay, thermal decomposition. This process is called thermal decomposition D. Okay, we move on. This is a limestone. This calcium carbonate is a limestone. Calcium oxide is a lime. So process of making lime from a limestone is thermal decomposition. Okay, we go. What is not the correct use of fraction named? Which one is not the correct use? They give you kerosene. Okay, naphtha is for making chemical. That's correct. Kerosene is for jet fuel. That's correct. Gas oil is a fuel in diesel engine. I think so. Fuel oil is used for making wax. No, I don't think A is correct. Yeah, A is not the correct use. Fuel oil is for lubrication. It's not for making wax. So A is the answer. They say which one is not correct. So A is the one that's not correct. So we choose A. We go to 36. Which reaction is not a reaction which alkenes undergo? Alkenes, they undergo bromination. Alkenes, they adopt the unsaturated. Carbon to carbon double bond. Carbon to carbon double bond. They are carbon to carbon double bond. So they can undergo, they can react with all the halogens. Okay, if it react with bromine, the reaction will be called bromination. If it react with chlorine, it will be called chlorination. If it react with iodine, same thing, iodination. Okay, so if it react with bromine, you know, it can react with bromine. For example, Z plus Br, 2 atoms of bromine can react with 2 atoms of bromine. Bromine atom is like this, right? Okay, we can say 2 molecules of bromine. Like this, right? 2 atoms of bromine, okay. So, to fill up, you know, it has 4 hydrogen. So, if you have with this, it will be 4 hydrogen and 2 bromine. It will now be 1,2-dibromoethane. 1,2-dibromoethane. It produces 1,2-dibromoethane. So, it can undergo. Which reaction is not a reaction which alkene undergo? So it can undergo this one, so it's not the answer. Hydration, you can undergo hydration, they have hydrogen and they form ethane. You can undergo hydrogenation with hydrogen. Hydration is react with water. This one react with water. Hydration is to react with water. Hydrogenation is to react with hydrogen to hydrogen gas to become ethane instead of ethene. Hydrolysis, no. It does not undergo hydrolysis reaction. Okay. So we go to question 37. Which substance can be obtained by cracking hydrocarbons? If you crack hydrocarbons, remember hydrocarbons are long chain alkanes. So if you crack them, you can get ethane. Okay. Which substance can be obtained by cracking? You can get one alkane and one alkene. So let's look for the one that has one ethene, or you can even get hydrogen if you crack, right? If you crack, you can get, but you must get one alkene, like ethene. So ethanol and hydrogen, no. Ethanol and ethene, no. Ethene and hydrogen, yes. Ethene and polyethylene, no. So the answer is C. Now, ethanol is produced by fermentation or from ethene. Ethanol is produced by fermentation. These are the 2 methods of producing ethanol. If you want to make ethanol, you either ferment the alkane, you ferment the ethene, or you react it with other means like steam. Okay, you react with the steam, you can get ethanol. Now, what is a disadvantage of producing ethanol by fermentation? The disadvantage, you know, first of all, fermentation is a long process. You have to leave it for like 3 days to ferment for this yeast or all these good things to react with it. It's a long process. It's a slow process. So what's the disadvantage of producing ethanol by fermentation? Distillation is needed to purify the ethanol produced. Yes, there's a disadvantage. You have to distill it. Because you left it outside for 3 days. You have to carry out distillation, okay, to produce the clean one. So that is a disadvantage. But let's see if there are more superior answers. Fermentation uses glucose from plants. Yes, of course. That's not a disadvantage, it's a reality. Fermentation is catalyzed by enzymes in yeast. It's a normal, it's not a disadvantage. Fermentation occurs at low temperature and pressure. So I think the answer is the disadvantage. The only disadvantage here is that after you get your ethanol, you still have to go and distill it because it's not pure. To remove the purity, you have to distill it because you left it outside for like 3 days. Okay. 39. Which structural formula represents methyl propanoid? So we look for propanoid. 1, 2, 3. CH3, CH2, COO. This is a propanoid. From here to here is a propanoid. And CH3 is methyl. So methyl propanoid is A. We can look at the rest, but A is absolutely standing. Okay, this is methyl CH3 the ethanoate, propanoate, sorry. Because it must have 3 carbon to be propanoate, and COO to be it, to be an ester. Okay, this is methylpropanoate. This one is 1, 2, 3. This is 1, 2, 3, 4. Okay, if you are going this way, 4. This is butanoate, methylbutanoate. This is 1, 2, 3, 4. This is also methylbutanoate, another way around. 1, 2, 3, 4. This is completely wrong. So the answer is A. So the last question, but not the least. Okay? We say, we should describe addition polymerization and condensation polymerization. Addition polymerization and condensation. In addition polymerization, the monomers, they are usually a team. So the answers are between A and B. Because it's a unsaturated hydrocarbon, carbon to carbon double bond. So the answers are usually this one. We be here, we be in A and B, not here. The monomers have a carbon to carbon double bond bond, and the polymer is only the polymer is the only product for addition. Okay, let's look at the condensation polymerization. The monomers have a carbon to carbon double bond. No, for condensation polymerization we don't have a double bond for the polymer. Okay, A is wrong. So B will absolutely be the answer. Monomers have a carbon to carbon double bond, and the polymer is the only product. That's correct. The monomer for condensation polymerization, the monomers react to form polymers and small molecules. Yes, they form polymer and water usually. So this is the correct one, most correct one. So with this, we come to the end of today's class. Okay, we come to the end of this class. Thank you for joining us. Subscribe to IGCSE Academy.